false position method could be defined as a closed method for solving nonlinear functions that almost same as bisection method.
To define interval, if our output A is less than 0, then we know that our function must cross the x-axis at least once. We have a negative output for input A.
Next, to find C, we have to use the equation of the second line as shown in the picture. The output product test have to be applied in the equation to see whether the direction of C moves to the left or right. If FA times FC less than 0, we have to type in YES. And if FB times FC less than 0, we have to type in NO note. If the root lies to the left of B, so B will be taken on C's value. This method is often used because it is faster than bisection method for finding roots. We also have to repeat the process until acceptable error is reached. The error equation is shown as in the picture.
Let's take a look at the example. Given fx is equal to ln 3x minus 3. The first step is to define the interval, and we will use the value of xa equal to 1 and xb is equal to 10. By substitute back the value of x, we'll get fa negative value and fb positive value. This means that the value of fa, fb is less than 0 and the line only cut x-axis once. The next step is to find c value. By substitute back the value of a, b, fa and fb into the formula, we will get the value of c, 8.434. And we have to substitute the value of c into the function back to get the value of 0.231. By looking at the value of b and c, we can conclude that the root lies on left of b. So we can conclude that b is equal to c.
Okay, the first step to make the false position method in that set is we have to draw a table here. We have iteration a, sa, b, sb, and so on. And here's our function, which is fx equals to 4x squared plus 3x minus 3. Here the iteration are equal to 0 and a is equal to 0. So how can we find the sa? So sa is basically we just substitute the value of a inside the function fx equals to 4x squared plus 3x minus 3. So how to make it easier? We can do the function just like this up here.